All right, let's get started with section R1, review section 1. We're going to go over some real numbers. So let's go ahead and get started. So objective 1, we have a number of objectives to work with, and the first one here is how do we work with sets. So again, this is stuff that you've seen in algebra, a little bit of geometry in this section, but R1 is going to be all algebra stuff, and so you should have seen it before, so we're going to move fairly quickly through it. Again, anytime, we talked about this in class a little bit, anytime something is a little confusing for you, feel free to pause it, grab the textbook. Everything you're seeing on the screen here is coming out of the textbook. All right, you can try to read the textbook. And after that, if it's still confusing for you, you're done. Make a little note in your notes saying, I don't understand this part. We're going to go over it in class. All right? So after trying to understand it in the video, maybe flipping through the textbook for a little extra explanation. If it's still not making sense, move on. Okay, I do not want you spending 7 hours tonight trying to get through this video. It shouldn't take that much time. So, all right, so sets, the set D, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 up here. All right, not 1.1 or 2.1, just the numbers 1 and 2 and 3 and so on. And you'll see here, we read this, x such that x is a digit. The key one here, this bar here, is the such that, a restriction. All right, so there's a little bit in the textbook about set builder notation. We don't talk about it a lot other than to say this. If I have this set, 0, 2, 4, 2, we don't need to write that second 2. That's the exact same thing as writing 0, 2, and 4. All right, 2 is in the set no matter how many times you repeat it. All right, so a little definition here. Now, depending on how you take notes, you may want to just write this whole thing down. Maybe you're just an audio learner and you just want to listen to it. Whatever works best for you, but let's go through it here. If A and B are sets, the intersection of A and B, A with B, and we denote it with the upside down U, A intersected with B, is a set consisting of elements that belong to both A and B. The union of A with B, which is the right side up U, right? Union U, is a set consisting of elements that belong to either one. If it shows up in A or B, we put it in the new set. So let's take an example here. So we have the intersection of A and B. If this is A and this is B, what shows up in both of them? 2 does, so does 4, and that's it. So the intersection of A and B is 2 and 4. All right. So we could do the union of A and B. That would be everything that shows up in either one of them. So 1 shows up, and so does 2, and 3, and 4, and 5, and so does 6. All right, those are all the numbers that show up in either one. Okay? All right, and then the last one here, B. Now this is a little confusing. We're going to work inside out. All right, the intersection of B with the union of A and C. So the union of A and C would be 1, 2, 3, 4, 5. And then C also adds in a 7. And then B is 2, 4, and 6. So what shows up in both of them? 2, 4, 2, and 4 again. And that's it. That's the only overlap. So our union here would be 2 and 4. All right. So now this little symbol right here is saying you need to stop, go into your textbook, go to the end of chapter R1 and find problem 13. If you're looking in the textbook, it says now work problem 13. All right, this is what I'm going to be checking you on for your homework. All right, so try problem 13. All right, now remember, it's an odd problem. Where do you find answers to odd problems? That's right, back of the book. So try it, check your answer. If you can't, after just a few minutes of trying, can't get the right answer in the back of the book, put a star on it. Okay, we'll talk about it in class. Oh, sorry, one thing. Pause the video when you see these. I'm not going to add in some extra time. Pause the video. When you're done with problem 13, press play. All right. right, let's talk about a complement. The complement of A, denoted A bar here, is the set consisting of all the elements in the universal set that are not in the original A. All right, so complement here of A would be everything in U that's not in A. So 2's in A, so we don't want that, but 1's not, so the complement would be, that's an ugly symbol, but we'll bracket, we'll keep moving. 1, we're not going to use 2, we're not going to use 3, we're not going to use 4, but we hit 5, not going to use 6, because that's already in A, but then 7, 8, and 9. All right? So that's the idea of a complement. Let's go ahead and skip B and C and jump right to 17. Pause the video, go ahead and try problem 17. All right, moving on to Venn diagrams. If we have the universal set of A, B, and C, we have these elements where they overlap, and that's what we're going to talk about. So, a universal set here, okay? A subset, A is completely inside of B. That means A is a subset of B. All right? The intersection of A and B doesn't exist. We're disjointed here, right? There's no overlapping at all. So subset, one inside the other. A disjoint set, A and B not overlapping at all. And now we have an intersection of A and B right in here. Anything that's in here would be the intersection. So that's how we can look at it visually. All right, and here's a union. That means anything that shows up anywhere, so the whole thing's blue. And then we have the complement of A. Everything that's in the universal set that's not in the A set would be A bar, the complement. All right, let's move on to objective 2 here. We're going to classify some numbers. So we've got integers. You guys know about these. You can have no decimal, negatives and positives and zeros. We've got rationals, which means we can divide. All right, and so on these, 1.2 is going to be rational. 1.27935, not going to be rational. All right, if it stops or if it repeats, we're going to be rational. All right, so we have a couple options here. 1, 1, root 2. We've got pi is c over d in this case. All right, so think to yourself, which of them are integers and which of them are going to be rational numbers? All right, and maybe some aren't irrational numbers. This is what we're going to be working with. All right. Together, rational and irrational numbers form real numbers. So real numbers is almost everything that we're going to be dealing with. We'll get to some non-real numbers, but not for a little bit. All right, moving on. So we can see this here. Natural or counting numbers, that's 1, 2, 3. Whole numbers adds in the 0. Integers adds in the negative. Rational adds in the decimals. Irrational adds in the non-repeating and non-ending decimals. Should be a review from algebra for us. All right, so let's classify these numbers in here. List the numbers in the set and figure out which ones are natural, integers, rational, irrational, and real. All right, first things first, they're all real. D, the irrational numbers. Which ones don't stop, don't repeat? Anybody? Okay, let's talk about pi, 3.14159. That's not stopping, it's not repeating, irrational. All right, so how about some rational numbers in here? That's going to be 5.212121. That's rational. So is 4.1. So is 0. So is negative 0.12. So is negative 2/3. Integers, we're going to lose that. We're going to lose that. We're going to pick up 0. Okay? And natural numbers, are there any natural numbers? There are not. Starts with 1 for the natural numbers. Whole numbers, we would pick up the 0. All right, jump to problem 23. Pause the video. Give that a shot. All right, approximations. Truncation means we just lose the digits. So for truncations, if we had 1.958 and I said truncate to 2 digits, boom, 1.95. If I said round it, obviously we're going to, you've done this before, 1.96. You would round up. All right? So truncation is maybe the one you haven't seen before. That means just lop it off. All right, there's some examples. And so you guys know how to do this. Let's jump to problem 27 and see if you can do some rounding for me. All right, significant digits. Leading zeros are not significant. In this 0.0034 number, that's 2 significant digits. Embedded zeros are significant. 208 has 3 significant. So difference between embedded and leading zeros. And trailing zeros are significant only if the decimal point is specified. For example, 2800 has 2 significant digits. However, if we specify the measurement is accurate to the ones digit, then we have 4 significant digits because we know that it's exactly 0 and we're not rounding off and just kind of approximating. All right, on a calculator, we're going to talk a little bit about your calculators here in class. I'm going to kind of move through this quickly here. You've seen these things before as well. Just remember the words quotient, product, difference, sum for addition, subtraction, multiplication, and division. We're going to have to be able to write statements using symbols. You guys should know how to do this from algebra. All right, so let me throw a quick one up there for, I'll just do A. The difference between 9 and 4 is 5. 9 minus 4 equals 5. You guys can do this. Pause it. Give me problem 39. All right, objective 3. Moving quickly here. Evaluate numerical expressions. All right. We agree that whenever the two operations of addition and multiplication separate 3 numbers, we do multiplication first and then addition. This is the stuff we're talking about. You guys know order of operations, all right? Do 51. Make sure you get the answer right in the back of the book. Try to do it in your head without using a calculator. You can do these numbers without the calculator. All right, I'm going to move through this quickly. You guys should know the order of operations, okay? We will do this a little bit in class, but we're going to move fairly quickly through these. The one thing I'll put up there, you may have not seen this, I think a lot of you have, is PEMDAS, parentheses, exponents, multiplying and division, addition and subtraction. That's our order of operations. All right, so 2 more problems for you to do, 57 and 65. All right, let's wrap things up. This is our last objective here. Work with the properties of real numbers. All right, these are all in your textbook. If you really like having them in your notes, pause the video. You can get them down. You've done them before, but let's just run through them quickly. Reflexive is like the mirror. A equals A. Symmetric, okay? A equals B, you can turn it around. B equals A. Transitive, if A equals B and B equals C, we can jump straight from A to equals C. And the principle of substitution, that if A equals B anywhere you see A, you can write down B instead. All right, commutative properties, that means you can flip these around or put them in the mirror. Same going forwards as backwards. Okay. Associative, right here, that means that you can, 3 plus 4 is the same as 7, right? We can rearrange the parentheses on these. So, associative, rearrange the parentheses. Works with addition, not so much with subtraction or division. And lastly, distributive. We're going to distribute in here. A times B plus C is the same as A times B plus A times C. All right. Hopefully this is shaking some cobwebs off your brain. Get that summer math back, and hopefully you've been doing a little math over the summer. Maybe, maybe not. Problem 87, yours to try. Make sure you get it right. Check your answer in the back of the book. All right, identity properties. If you add 0, you don't change. If you times by 1, you don't change. There it is. And additive inverse. If you add opposites together, you're back to 0. If you multiply by the reciprocal, you cancel each other out. Okay? Now this is the one that I think most people forget, and I'm going to use a lot. Multiplying is the same as division flipped over, right? So anytime they want you to multiply a fraction, maybe let's divide and flip it over. Or if we want to divide a fraction, let's flip it over and multiply. Little tricks. All right? Difference, quotient. You guys know about these. You multiply by 0, it gets 0. You divide, 0 divided by something is 0. You divide by itself, you get 1. Moving quickly through all these. And lastly, signs, you guys know this. If they're not the same, you get a negative. If they're the same, you get a positive. Whew, we're moving quickly. A lot of things to review. Dust off the cobwebs here. Cancellation on this. AC equals BC means that A equals B. You can cancel out the C's. And the last one here, I believe it's the last one. We'll find out. Zero product. If AB equals 0, then A is 0 or B is 0 or both. One of them's got to be 0 if you get 0 in the end. All right, arithmetic of quotients. We've got our fractions here for adding fractions. Get it? What's this called? BD? Common denominator. If we're adding fractions, you need a common denominator. If you're multiplying fractions, you don't. If you're dividing fractions, we're going to multiply by the, what's this called? A reciprocal. There you go. So never divide two fractions. Instead, multiply the reciprocal. All right, 3 problems for you to do here, 67, 71, and 81. Do we have one more? Oh, that's right. Least common multiple. All right, find the least common multiple of 12 and 20. All right, I'm not even going to go into that. I want you to see if you can remember that one. Try problem 75. All right, and I think we'll be all right. That's it. We went through this very quickly. Most videos will take our time because it's going to be new stuff. This was old stuff, so we went really quickly. But that being said, if any of this was maybe totally new or really shaky, make sure you made some stars or some notes on your work so we can talk about it tomorrow in class. All right, good luck with all of this, and I will see you all next class.